Here we go, the notes for solving rational equations. So rational equations contain a variable, usually x, could be any letter though, the denominator of a rational expression. So a rational expression is just a fraction, denominator is the bottom, so it means we usually have x's on the bottoms of fractions, like that guy. So here's our solution steps. So step 0 doesn't always happen, not necessary, but if possible, factor any denominator. So that could be a greatest common factor or factor in a quadratic. After that, we need to figure out our least common denominator. Each individual denominator must be able to be formed by using parts of the least common denominator. So the least common denominator has to contain all of the other denominators within it. After that, we're going to multiply each term by the least common denominator, so we can write this one of two ways, depending on how comfortable you are with fractions work. So option 1, you multiply the numerators only, the tops of the fractions, by the LCD, and then cancel any terms or quantities that appear in both numerator and denominator. Option 2, you can cancel as you go. Terms shared by the LCD and the denominator of each rational will immediately cancel. The numerator will then multiply by any terms that did not cancel. So I'm going to do the first one with option 1, and then I'm going to switch over to option 2. So after that, simplify what we have left, multiplication, combining like terms, etc. for solve. And then 5, we do have to check our solutions. Because we have fractions, we are not allowed to divide by 0. So in the case that our solution causes us to divide by 0, we can't actually use that value. Just a note on canceling, so x plus a number and a number plus x can cancel with each other. They'll give you 1, so like x plus 2 and 2 plus x, that's the same thing. For subtraction, you can cancel them, but because they're in opposite orders with a negative sign, you actually cancel and get -1 instead. Okay, so looking at our examples. So we have x over x minus 8 plus 3 equals -x over x minus 8. So for this problem, our least common denominator is just x minus 8 because it is the only denominator that appears. We don't need it twice because the least common denominator, how to phrase this, because each denominator has only one copy of x minus 8, the least common denominator only needs one copy of x minus 8. So what we're going to do is we're going to multiply everything by x minus 8. Now, because this is technically a whole number, it's over 1, and when you multiply fractions, you multiply only into the numerator. So remember, I'm doing option 1 up here. We're going to multiply the numerator. So this first fraction becomes x times x minus 8 over x minus 8 plus 3 times x minus 8 equals -x times x minus 8 over x minus 8. So this x minus 8 multiplies everything inside, tops of fractions, numbers. Then we cancel. So x minus 8's top and bottom there, x minus 8's top and bottom there. So this first fraction is just x, because the x minus 8's are gone. This is 3 times x minus 8, and this is just -x. So now it's just clean up. So x plus 3x minus 24 equals -x. So if we bring that over here, that's 4x minus 24 equals -x. So I'm going to bring the 4x over here. So -24 equals -5x. So x would be 24 over 5. And to check, if I take 24 over 5 and plug it back in, 24 over 5 minus 8 isn't 0. So that answer works. All right. So for number 2, our least common denominator would be x minus 5. It's the only denominator we have. So everybody gets multiplied by x minus 5. So I'm going to cancel as I go and show what that looks like. So when I multiply by the first fraction, the x minus 5's cancel, so I'm left with the negative and the 4x. In the middle, no, there's nothing to cancel, so the x minus 5 shows up. And on the right-hand side, x minus 5 cancels with the x minus 5, leaving me the negative and the 5. So do our distribute. Combine like terms. And solve for x. So it's a quick check. If I plug 2 in, 2 minus 5 is not 0, so our solution is valid. So for 3, our least common denominator is going to be x plus 1. So everybody gets multiplied by x plus 1. So 1 times x plus 1. For the middle, the x plus 1's cancel, leaving me the plus and the 1. On the right-hand side, the equal sign, x plus 1's cancel, leaving me the negative and the x. So x plus 1 equals -x. So 2 equals, if I bring that guy over, that's going to be -2x. X equals -1. check your solutions. If I plug -1 in, this becomes -1 plus 1. So does this. -1 plus 1 is 0. I'm not allowed to divide by 0, which means this one actually has no solutions. Same least common denominator here. So everybody times x plus 1. So 6 times x plus 1. In the middle, x plus 1's cancel, leaving me the negative and the 1. On the right-hand side, just the x's left over, x plus 1's cancel. So 6x plus 6 minus 1 equals x. So that's 6x plus 5 equals x. We're going to move that guy over, so 5 equals -5x. X equals -1. So once again, can't use -1. No solution. If I use -1, these fractions become divided by zeros. All right, so this one, I noticed on 5 and 6, well, when we get to 6, there's an x here on the right, which means our solution is going to look a little bit different. So x plus 8 is our common denominator. So x times x plus 8. In the middle, these x plus 8's cancel, so I'm going to have the negative sign. Now, you have to be careful if you have more than one term on the top of your fraction, because when these x plus 8's cancel, I still have this x plus 3. But even though there's technically nothing multiplying it, it needs to go in parentheses to keep track of that negative sign. The right-hand side, 5. So this is going to become x squared plus 8x minus x minus 3 equals 5. If you forget the parentheses, you'll end up with -x plus 3 here, which means your solution won't come out right. So because we have an x squared, everybody's going to be on one side. So I'm going to combine like terms and move the 5 over at the same time. So that's x squared plus 7x minus 8 equals 0. So if you have quadratic, you have two solution methods. You can factor or do the quadratic formula. I prefer to factor. So I need two numbers that multiply to -8 and add to +7. That's +8 and -1. So the two possible solutions are -8, because -8 plus 8 is 0. And +1, because 1 minus 1 is 0. Check your solutions. If I use -8, it makes these fractions become zeros, so I can't use -8. 1, though, does work. All right, last one. So on 6, we actually only have one fraction, so it is our only common denominator, so everybody times x plus 2. So x times x plus 2. In the middle, the x plus 2's are going to cancel, leaving me just the 3x. And on the right-hand side, nobody cancels, so the x plus 2 still shows up. So x squared plus 2x plus 3x equals 2x plus 2. Because I have an x squared, everybody to one side, so I'm going to move everybody left to be with the x squared. So in this case, these two x's actually cancel, so I just have 3x minus 2 equals 0. Bring them up here. So a quadratic equal to 0, so we factor. So I need two numbers that multiply to -2 and add to +3. That would be... Are there numbers that work? Or have I made a mistake somewhere? Oh, nope, that should be a 4, which means that is a 4. So two numbers that multiply to -4 and add to +3. That would be +4 and -1. So the two possible solutions are x equals -4, because -4 plus 4 is 0, and +1, because 1 minus 1 is 0. If I check our work, -4 plus 2 is not 0, so that's okay. If we plug 1 in, 1 plus 2 is not 0, so that one's okay. And that brings us to the end of the section.